Welcome to True Projects. In this video, we are going to explain about the project that is AdaBoost.RDT, that is AdaBoost integrated with residual based decision tree for demand prediction of bike sharing systems under extreme conditions. Before getting into the execution, first let us understand what is the project about. Imagine that you are in a busy city and you need a quick ride to get to your meeting, or you just want to take a leisure bike ride through any other place that you want to go. So here, bike sharing systems makes this possible, providing easy access to bikes through apps or station kiosks. They are not just a convenient option, and they also play a key role in making urban transport more sustainable by reducing air pollution and also easing traffic. In cities that are rapidly growing, these systems are becoming a vital part of how people move around. However, while BSS, that are bike sharing systems, are incredibly useful, they do face a significant challenge. That is, demand for bike isn't always balanced across stations. Sometimes you might show up to a station ready to rent a bike, but find that there are no bikes available. On the flip side, some stations may have bikes, but all the docks are full, preventing people from returning bikes. This imbalance in demand causes frustration and disrupts the smooth functioning of the system, making it harder to rely on bike sharing systems when you need them most. It is a critical issue that needs to be addressed to ensure that these systems can work efficiently and also keep up with the needs of the growing number of users. When it comes to bike sharing systems, predicting how many bikes will be rented at given time is crucial for keeping the system running smoothly. If we can predict the number of bikes that will be rented, we can ensure that bikes are available at popular stations, that there is enough space for returns at the other. Here, machine learning algorithms, particularly ensemble based methods like boosting, have shown promise in forecasting this demand. However, these methods can struggle when it comes to predicting extreme events such as sudden surge in rentals, like during a festival or special event. Here, this bias towards extreme events can lead to inaccurate predictions, either overestimating or underestimating the demand, and that impacts the balance of bike across stations. So, the challenge is to develop a predictive approach that is not only accurate under normal circumstances but also capable of handling these sudden surges in the demand with better prediction accuracy for both the regular and extreme events. Bike sharing system can optimize their operations, ensuring bikes are available when needed and making the system more reliable for users. So, to tackle the challenges of predicting bike rental demand, especially during unexpected surges, the proposed system introduces a new boosting algorithm called AdaBoost.RDT. Traditional boosting methods and even noise robust algorithms often struggle when it comes to predicting extreme events like sudden spikes in the demand for bikes. What sets AdaBoost.RDT apart is its ability to improve the accuracy of predictions during these extreme demand scenarios while still performing well under normal conditions. And in this system, we are incorporating, that is, we are using bike Seoul data set for predicting the bike demand. This provides real world data on bike rentals. By training the algorithm on this data set, the system can better predict when and where the demand for bikes are. Coming to the algorithm part, AdaBoost.RDT works well by combining two key components to improve predictions for bike rental demand. So here, adaptive boosting and residual based decision tree, that is RDT, is combined. So first, the base model, adaptive boosting model, is trained to predict the demand based on the data. This is the initial prediction made by the system. However, no model is perfect and there are always some errors in the predictions. That is where the residual based decision tree comes in. So, the second model is designed to identify where the base model has made mistakes, specifically where it has underestimated the demand. The RDT focuses on these errors and predicts the residuals, that is the difference between the base model's prediction and the actual prediction, that is actual demand. And here, these residuals are then fed back into the system as additional features during the next iteration, allowing the model to refine its predictions by adding this layer of refinement. AdaBoost.RDT helps correct bias, especially when it comes to extreme demand scenarios like when there is sudden surge in the bike rentals. This method ensures the system not only gets better at predicting the usual demand but also improves the accuracy for those rare extreme events that can really throw off a standard model. To further improve the accuracy in this project, we are combining three powerful algorithms, that is the proposed model AdaBoost.RDT and the XGBoost and Random Forest, into one ensemble system. Each of these algorithms has its own strengths, especially when dealing with the extreme demand scenarios and the challenges of the system imbalances. By combining them, the system benefits from the unique strengths of each algorithm, improving its overall accuracy and performance in predicting both regular and extreme bike rental demands. And top of that, the extension includes the development of a Flask-based front end. This interactive platform allows users to test the system and provide a way to evaluate how well the demand predictions work in the practice. Front end also includes user authentication, ensuring that only authorized users can access and test the system. This makes it not just a theoretical tool, but one that can be actively used and assessed for testing purpose. Moving to the implementation, to implement this project, we have followed the steps of the flow of work. So first we have imported all the necessary libraries and packages that are important, like Pandas, NumPy, Matplotlib, Scikit-learn, and Flask are imported for data manipulation, model building, and creating the web application. Then the next step is exploring the dataset. So here the dataset is loaded and explored to understand its structure, identify missing values, and get insights into the data features. So here Seoul bike data has been loaded. After that, pre-processing is done. Here we duplicate entries are identified and removed to ensure data accuracy. Here we remove the duplicate data and then we do drop cleaning. That is, unnecessary or irrelevant columns are dropped to focus on the key features for prediction. Then comes the visualization part. Visualizations like graphs and plots are created to better understand the relationships between different variables and trends in the data. Then we have encoded all the categorical variables into numerical. That means here we did label encoding. Categorical variables such as day names or weather conditions are encoded into numerical values to be used in the machine learning models. Coming to the next part, feature extraction. So here the data set is split into features as X and the target variable as Y, which is in this case the bike demand is to be predicted. So that will be Y. Then the data is split into training set and testing set. Training set is of 80% and testing set is of 20%. Testing set is nothing but validation set. Training set is used to train the models. Validation set is used to evaluate how the models are performing. Then we initialize the model. So multiple machine learning models are built. Here they are initialized. That is the AdaBoost model and the RDT model is both models are initialized here. And then they are trained on the training set of the data to learn patterns and relationships between the features and target variable. Then we evaluate all the models using MAE, MAPE, and RMSE, which are different error metrics used to evaluate the regression models. Then we compare all them through graphs. Coming to the part of front end, here a web application front end is developed using Flask, including a user registration login system with SQLite database for storing user credentials. And here in the front end, user will be able to specify their input for predicting the bike demand. And then it will be pre-processed at the backend and that will be fed with the trained model. Finally, demand will be forecasted in the front end. So it will be displayed in the front end. Coming to the algorithms used, these are the algorithms used. This is the proposed model and this is the extension model. To implement this project, we need basic requirements, which are hardware requirements and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let us execute the project. To execute, we need to open the code folder of the project, which contains source code files. So these are the source code files in the code folder of the project. Let us open the dataset folder. Here, this is the dataset that we have used in this project. So this is the dataset that is used to train the models for predicting the bike demand. So these are all the features, and even this is also the feature. These impact the rented bike demand. So this is the target column that we are going to predict. Let's close this. And here we have the test cases that we will be using for predicting the bike demand. Let's close this. Get back. And in this model folder, we have the algorithm information that will be loaded into the project code during runtime. In this, we will be having .hy files, pickle files, and numpy files. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. And in this folder, that is the templates folder, here we have HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in paper, that is code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is copy of that. And this is the signup.db file. This file is a database file which is used to store the user information. We have understood all the files. Now let's execute. So copy the path. To execute, we need to copy the path of the code folder from the address bar of the file explorer. Copy it. Now open the command prompt. Give the command cd. Now paste the copied path. Give the space and then paste the copied path. Click on enter. Here, if you observe, current directory is changed to the code folder's path. Now we are supposed to compile the app.py file. So give the command python space app.py. Now click on enter. So this command will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. This is the local host and this is the port, unless configured differently. So now we need to copy this local link provided by the Flask framework and paste it into any web browser. I'm copying it. I've copied it. Now I prefer Google Chrome, so I will paste it in that. Paste the link here. Click on enter. So this is the web page of the project which is developed using Flask framework. We need to register first. Click on register and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see a choose file button, right? We need to click on that for uploading the test case file. Click on that. So here in this, we have the test cases. Before uploading this file, let us understand what are present in this test data. Let us open it. So here the first column which we have is the date. Date is when the data is recorded. This helps to identify trends over time, such as day-to-day or seasonal variations in the bike demand. And next we have is the hour. This is the specific hour of the day. Bike demand can vary by time of a day. So knowing the hour helps us to understand peak rental times and patterns. Then we have is the temperature. It is the outdoor temperature in Celsius or foreign heat. Temperature affects how people use bikes with higher or lower temperatures influencing the demand. And coming to the humidity, it is the percentage of moisture in the air. High humidity levels can make biking less comfortable, potentially affecting bike demand. Then we have is the wind speed. The speed of the wind in meters per second. It is the strong, if the strong winds can discourage people from biking, influence the demand. Then we have is the visibility. Visibility is measured in 10 meters increments. Poor visibility such as fog or heavy rain can reduce the likelihood of biking affecting the demand. Then we have dew point temperature. It is a temperature at which air becomes saturated with moisture and dew forms. A high dew point may signal more humid conditions affecting bike preferences. Then we have solar radiation. The amount of solar energy received from the ground in megajoules per square meter. Higher solar radiation may indicate sunny weather, which could lead to more people using bikes. Then we have rainfall. It is the amount of rainfall in millimeters. Rain typically deters bike usage, leading to lower demand for bike rentals. Then we have is the snowfall. It is the amount of snow in centimeters. Snow can create unfavorable conditions for biking, leading to reduced demand during snowy weather. Coming to season. The season of the year, it may be spring, summer, fall, and winter. Seasons impact weather conditions influencing bike demand. More rentals in the summer, for example. Then holiday. It indicates whether the day is a holiday. People may have different bike usage patterns on holidays, either using bikes more for leisure or less due to travel or other activities. Then the last one is functioning day. This indicates whether it is a functioning day, that is functioning working day, example weekdays. On functioning days like weekends, non-functioning days like weekends, bike demand patterns can change based on people's schedules and activities. So these all test cases we will be giving as input, and then we will predict the bike demand. Let's close this. Get back to the application. Let's upload this file. Click on open. Here it has been loaded. Now click on upload. So if you observe, all the inputs are uploaded. So for the first case, this is the case that we have uploaded for the given thing. Here we got the predicted bike demand as 207. It is the rental count of the bike. Similarly, for the second one, we got the prediction as 192 rental bike count. That is the bike demand. For the third one, it has predicted as 136. Similarly, for all the cases that we have entered, it has predicted. So the first one is day. Similarly, the next one is temperature, humidity, season, functioning day, whether it is a holiday or a functioning day. It is all uploaded. So these are all the inputs that we have given. For all the given inputs, we got the prediction. Now let's check with the graphs. Click on graph. So here the first graph, visualization graph as the box plot. So these are the two box plots that we have. So this graph represents the Seoul weekdays demand prediction graph of the extension model. So this is the prediction of extension model. So here we have two box plots. One, the first blue color box plot represents the count of the rented bikes, and orange color predicted box plot represents the predicted count of the rented bikes. And this is the prediction done by the extension model. If you observe, both of them are equal. That means that model is performing well in predicting the count of bikes rented. And here we have mean average percentage error. So here on x-axis, this we have MAPE score, and on y-axis we have all the algorithm names. Here if you observe, extension model is having the least error rate than the other models. And this is the RMSE comparison graph. Here also on x-axis we have RMSE score, and on y-axis we have algorithm names. Similarly, we also have MAE graph. Now click on logout. In this widget, by giving the input to the system, this will predict the bike rented demand. It will predict the demands for the bikes. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.